Section 5.6 video, part 5, we're going to continue factoring trinomials, the harder case. This is what we refer to, what I refer to as the Brew method. And so let's look at another one here. Now remember, you got to check for a GCF first. That'll be important in just a minute. There's no GCF. Next then, this is the trinomial, but it is not the easy case because of that 2. So what do we do? What do we do with this 2? What do we multiply it by? Multiply it by 7. So you come to the side, a squared minus 5a minus, and then 2 times the 7 gives you 14. Now remember, when you do this, this is a completely new problem. So the answer to this problem over here is not the answer to this problem over here. All right, let's do this one because it's the easy case now. So a squared breaks up a times a. This tells me the signs are different. Largest is negative. So my largest number is going to go right here. Now the last two questions. Two numbers that multiply to give me 14. Subtract to give me 5. Multiply 14, subtract 5. Well, that's 2 and 7. But you need a negative 5 out of that. So you need to make sure the 7 is with the negative. Biggest number is negative. Signs are different. Largest is negative. So that's 7 and 2. We are not finished. We haven't even done the Brew method yet. So under the bottom of these two numbers, put the number that you started out multiplying by, which was 2. This is a 2, and that's a 2. R stands for reduce. 2 over 2 reduces to 1. 7 over 2 does not reduce. And then the last letter, U, stands for up. If you still have a fraction, we don't right here. You do, but the bottom number is 1. But you do have a fraction here, bring that number up. And when you do that, those are the two binomials that would multiply together to give you this original problem. And remember again, you can also FOIL this if you wanted to double check it. Okay. Now, what I want you to do in this next problem is I want to show you something just for a second. I do not want you to write this down, because if you write it down, you're going to have to turn right around and change it. So watch this problem right here just for a second, and I'm going to go through it in a hurry. Okay, this is a trinomial. Now, let's suppose you took this trinomial and you went straight to the Brew method. So what do we do with this number on the end? 4 times 6 is what? 24. So I multiply that number on that times the number on the end. Now let's factor this. X squared breaks up x times x. Signs are different. Again, largest is negative, so the biggest number is going to go there. I need two numbers. When you multiply them, you get 24. If you subtract those same two numbers, you get 10. 12 and 2. Multiplies to give you 24, but if you subtract 12 and 2, you get 10. So I've got to put the 12 with the negative, the 2 with the positive. Now we're not finished. Now we've got to do the Brew method. B, under the bottom of the numbers on the end, put the number that you started out multiplying by, which is 4. R is reduce. 2 over 4 reduces to a half. 12 over 4 reduces to 3. Now the letter U stands for up. Bring this number up. And so I've got 2x plus 1, x minus 3. Now this is what I want to show you. If this is the right answer, and by the way, I didn't make a mistake going through here. I mean, I did the Brew method properly. But watch what happens if I check this answer. 2x squared minus 3x plus x minus 3, which is 2x squared minus 2x minus 3. If you'll notice, that doesn't give me the original problem. So that means then that this is not factored correctly. Now you said, Mr. Ryan, I watched you go through that. You didn't make a mistake on the brew method. I didn't make a mistake. I did the brew method exactly like I needed to. Remember, in mathematics, the order in which you do things in many instances matters. When you are factoring a trinomial, if it has a GCF, and you skip past that and you do the brew method, you end up getting a bogus answer, an answer that doesn't work. So that's why every single time I've been putting these up, I've always said that. And even though most of the ones we've done didn't have a GCF, because if you do these things out of order, it gives you a wrong solution. So in any trinomial, this is the process you think in your head. Does it have a GCF? Is it the easy case? And then is it the harder case? That's your thought process at this point. So let's go back now and look at this problem. Now, I do want you to write it down now. So let's go 4x squared minus 10x minus 6. Okay, first thing I look for is, does this have a GCF? Yes. The GCF is 2. You got 4, 10, and 6. Now remember, when you're looking for your GCF, always check for letters also. But the GCF here is just 2. All right. 2 goes into 4, so this is 2x squared minus 5x minus 3. Now remember, I told you a couple of videos back, I told you the instructions will no longer say factor. The instructions will say factor completely. So if a problem factors multiple times and you stop before completely factoring, you will not receive full credit for that problem. So what I've got to do is I've got to see if this factors again. Now, you say, well, it will factor again. No, I don't know if it will or not. I can't just look at that and tell you. But I've got to check it to see. So what I'm going to do is I've got to see if this factors again. If it does, I'm going to put it right up under here. Now, as I told you in the previous video, if it does not factor again, I will circle this, and that's my answer. All right, so how do we factor this? Back all the way out where you're thinking. Check a GCF. We've already done that. Is this the easy case? No, because of the 2. So this right here, I've got to see if the brew method will factor what is in here. So that's what I'm checking for. So I've got to see if this factors again. And remember, if it does, don't forget to bring that 2 down. All right, so let me go to the side. Now, this is, and I could have been writing this all along. This over here to the side that you see is what I call my scratch work. You don't have to do it over, you can do it on a completely different sheet of paper. But in order to do the brew method, I can't do it in my head. So to do this, I've got to write it down. So how does the brew method work? Now remember, we're only looking at what's in this parentheses. So take the number that's in front and multiply it by the number that's on the end. So leave the x squared minus 5x the same, and then minus, now 2 times the number on the end gives me 6. All right, when I do that, I have a completely new problem. All right, so let's factor it. X squared, x and x, signs are different. Largest is negative. Biggest number is going to go there. Now the 2 questions. two numbers that multiply 6, subtract 5. Multiply 6, subtract 5. 6 and 1. But I've got to put the 6 with the negative. Now, if that had been a plus right there, you'd be two numbers that multiply 6, add 5. Then I'd be using 3 and 2. Of course, both of these would be negative also. So that's why it's important that you understand the rules about the signs. Now, I'm not finished. Matter of fact, I haven't even started the Bree method. B, under the bottom of this 1 and this 6, under the bottom, put what you started out multiplying by, which was this 2, not 4, the 2. Now, R stands for reduce. So this would be x plus 1/2, and then x minus 6 over 2 is 3. And then now, if you have a fraction, bring that number up. There's no fraction over here, so I'm just going to leave that x minus 3. So I've got 2x plus 1, x minus 3. That is what I bring back over here, and that is the completely factored version. This is the completely factored version of the original problem. Okay, let's look at one more example, and this will be the last section 5.6 video, but this will also now enable you to do the 5.6 part B. Remember, the first 3 videos in 5.6 I did was for your 5.6a. These last 2 videos, number 4 and number 5, was for 5.6b. And then there is another section that just in your homework in MLP that says 5.6. That 5.6 is a mixture of the problems in 5.6a and 5.6b. So after I finish this one example right here, you should now be able to do 5.6a, 5.6b, and 5.6 in your homework. And then my next video after this one will begin section 5.7, part 1 video. But before we get to that, I'm going to do one more example with you. So let's do this one. 12x, let's see, cubed. Give me just a second here. I want to change something right quick here. All right, 12x cubed y plus 70 x squared y squared minus 12 xy cubed. All right, so the first thing I want to do is I want to look for a GCF. Okay, does this have a GCF? Well, 12, 70, and 12, I know 2 goes into every one of these. Now, let's look at the letters. X cubed, x squared, x to the first. I can take out an x. Y1, y2, y3, I can take out a y. So this one had a GCF of 2xy. Now let's divide. 2 into 12 is 6. X into x cubed is x squared. Y into y completely cancels. Plus 2 into 70 is 35. X into x squared is x. Y into y squared leaves y. Minus 2 into 12 is 6. X into x cancels. Y into y cubed leaves y squared. All right, so what I did here was I took out a GCF of a 2xy. Now, I'll show you something right quick just to remind you. Remember, you can check to see if you took out the biggest amount, there should be nothing else common here. Is there anything that goes into 6 and 35? No. 2 won't go into both, 3 doesn't go into both, so there's nothing that goes into 6 and 35. Also, notice, do you have an x in every term? No. Do you have a y in every term? No. So that means you took out the biggest amount. Now what I need to do is see if this will factor again. Now remember, this x squared is going to be an x and an x. That's why there's an x in the middle. So when we break up this y squared, we did one this like this several sections back. We're going to break, when we break this 6 up, we're going to have to put a y behind both of those numbers. But we got to figure out what works first, if it even factors again. So let's see if this factors again. If it does, I'll put it in those 2 parentheses right there. All right, so I'm going to come to the side and do my scratch work. So let's see, I'm going to take this number on front and multiply it by the number that's on the end. So leave the x squared alone, plus 35xy, and then 6 times 6 is minus 36y squared. I don't know if you're going to be able to see all that or not. Let's see. 36. Yes, okay, you can see all of that. Okay, good. All right, so what I did was I took this number on the front, multiplied it by the number on the end. 6 times 6 is 36. Left everything else the same. Okay, now let's factor this. X squared, x and x. Signs are different. Largest is plus. So my largest number is going to go right there. All right, what 2 numbers do I use? I need 2 numbers. If you multiply, you get 36. If you subtract, you get 35. Multiply 36, subtract 35. That's 1 and 36. Because 1 times 36 is 36. But if you subtract 1 and 36, you get 35. So 1 and 36, but the largest needs to be positive. So I'm going to put 36 here and the 1 there. But when you break up this 36, you got to break up the y squared with it. So you're going to have to put a y on the both ends of that. And you don't have to write this 1y. You can just write it x minus y. All right. That's not the answer to this. We haven't even done the Brew method. B. Under the bottom of this and this, put the number that you started out multiplying by, which was 6. So put a 6 here and here. When I do, now I want to reduce. So this would be x plus 6 into 36 is 6y. And then 1 over 6 is just 1 over 6y. And by the way, 1 over 6 is not 6. 6 over 1 is 6. But 1 over 6 is 1/6. Now bring any numbers up that's still in the bottom. I have nothing to do here. But I do have something to do right there. Bring that number up and put it in front of the x. And that becomes 6x minus y. So bring this number up in front right here. Now, these 2 binomials is what goes beside the 2xy. So bring that back over here. This is the complete factorization of that trinomial. Now remember again, how would I check this if I wanted to multiply it out? I'd FOIL this first, and it should take you back to there. Then you distribute the 2xy, and it should take you back to here. So we've talked about factoring polynomials by looking for a GCF first, always. If it has 4 terms, we always use grouping. And then if it has 3 terms, you still look for a GCF first. Then you ask yourself, is it the easy case? That means that leading term has a 1 in front of it. Or is it the harder case where the leading number is not a 1, in which case I use what's called the Brew method. So this completely finishes all of the 5.6 homework in your MLP. So next video will be section 5.7.